able to see my screen?
Yes, Naren.
Okay, sure. Thank you. Thanks for confirmation. So, yesterday we have seen regarding the this is day 3, okay, and the date is 14/09. Okay. So, yesterday we have seen about the regarding the OLTP and OLAP, right? So, OLTP and OLAP. So, what is OLTP then? OLTP is an online transactional transactional processing. Okay, and same thing like OLAP is online analytical processing. Okay, so coming to the OLTP, so OLTP is nothing but it's a defined for day-to-day transaction. Okay, transactions. Okay, and also the main purpose of OLTP is like generally we do the operations like insert, update, and delete operations, right? So whenever the day-to-day transaction is done, like the new customer can be, registered in that application. The existing customer can say can update the details like suppose phone number and address and something like that, right? And also, if they don't want the account in the particular application or the bank, if so, receives a city bank, ICICI bank application, right? So they will close their account. So if they don't interest in that, so that is called deleting the operation, okay, delete operation, okay. So those things, but to improve these operations, generally this OLTP is designed like it is a normalized, okay, normalized database. Okay, so what is normalized means? It is a process of removing the duplicate data, or we remove the duplicate data. Removing the duplicate data, what is this means? We will get to know. We'll let to know like future classes. In future classes, once we are going to start with the SQL classes, right? Before that, I will let you know what is normalization or what is the normalization techniques are. But when the database is normalized, right? So these insert, the update, delete operations will be improve. The performance of these operations will be improved. That is why especially OLTP is designed for it is a normalized database. Okay, coming to the OLAP. So this is OLTP is nothing but what? It's a relational database. Generally, whatever the database is we are using, right? This is a relational database management system. Okay, relational database management system. And coming to the OLAP, online analytical processing, it is known as a data warehouse. Okay, it is also known as a data warehouse. Okay, so by using the analytical processing, right, this data warehouse, we do the future estimations. This is generally focused on analysis, right? Analysis, right? Analysis is nothing but we do the complete analysis of our business, like how the business is going on, right? And what will be the change, like what will be the changes we have to do in our business in a particular branch. Suppose if there is a business of like, suppose if we take in a DMart or something like that, so they will have a different branches in a different areas, right? So in they will choose some product, like they will keep some products in a their area, those branches, which product are selling more, right? Where there is a demand of a particular product, they will keep, they want to keep the product there more. Okay, the product availability should be there. Like that, they want to do some analysis of something like that, right? So these analysis also can be made by the data warehouse. Okay. And also with this, what we can do also future estimations of business, right? what will be the next 2024 budget for our business. So that can be also we can do, and what will be the employment growth in our organization, or way whether we have to reduce the employees in our organization according to the thing till now what we have done with all the projects, what is the proper profit we got. With that, can we maintain these employees or not? Something like that, they can decide by using the analytical process. Okay, and this is denormalized. Why? Because so analytical means analysis means you have to select the data for the from the particular data warehouse, right? So selecting data is nothing but it is a select operation is nothing but we are reading the data from the data warehouse. So we are reading the data and we are analyzing the data. That is why so that we can do the some future estimations and we can do the analysis, right? This is one operation that is called in SQL select operation. Okay, to improve the select operation, we are making this as denormalized, denormalized database. Okay, denormalization is something. Okay, where it is normalized, it is going to be a OLTP. Where it is denormalized, it is a OLTP. When in an interview, right? So when you're saying something like, so just go with the start with the OLTP is normalized and OLTP is denormalized. Why it is OL normalized means to improve the performance of inside of the delete operations because we perform the day-to-day transactions in OLTP. Okay, that's how you have to explain them so that the interview generally interview will explain we will expect this type of explanation. Okay, first thing they expect this normalization. Okay, then only they will get like if you say they online analytical done transaction processing and something like that, so it will not they will not get things. Okay, just explain them that OLTP is an online transaction processing. It is a normalized. Why it is normalized means we do the performance of we do the operations like day-to-day transaction that is inside of the delete operations so that if these operations should improve the performance so that it is normalized, the OLTP is normalized. Okay, fine. So these are things we have learned yesterday, and also we have seen the data mart, right? And the data mart is nothing but it's a specific to a business area. When we are developing a data mart, we are developing a data mart specific to a business area. Okay, specific to a business area. That is nothing but like employees area and sales area and product thing. So for those data separate, if you want to analyze those data separately, that is called as a specific to a business area. So those data will be loaded in a separate data marts from the data warehouse. These are two types. What is independent and dependent? Okay, these are the two types. Independent is nothing but once we develop the data warehouse, once we develop the data marts, then we clubbing all the data marts and we are loading the data into the data warehouse. That is called as independent. It is not depending on the data warehouse to be created, and that is no so that we call it as independent. Independent is nothing but once data warehouse will be created, and from that data warehouse, we will separate out the different business areas data into the data marts. So these data marts will be dependent on the this particular data warehouse to be created. That is not so that's why it is known as a dependent data marts. Okay, till now it is fine. And coming to today, so we are going to see about the as I said like yesterday, there is a in a data warehouse we have a two types of tables. One is fact table and other is dimension table. Okay, dimension tables. So what is fact table and all those things we'll see now. Fact table is nothing but it is a table where it contains the measures and facts. Okay, it contains the facts and measures. Okay, facts and measures. So what is facts and what is measures? So generally this facts is nothing but we can't change these facts. Suppose if you take as the employee ID, employee ID can be changed for an employee. No, right? Account number. Can it change? No. Customer ID. Can it change? No. These are the facts. We can't change these facts. Okay. So that is not, those things, those data will be available in a fact table. And also measures. Measures is nothing but suppose account premium. So suppose policy premium or account amount or balance. Okay. Or whatever the revenue of a particular product. Okay, these are the measures. Okay, these two things will be available in the fact table that is known as a. So based on these two things, particular like facts and measures, we will do some analysis that we will let you know. But in this fact, because based on the fact tables, so how this fact table can be defined based on the three types of facts. Okay, three types of facts. One is additive fact, and second is semi-additive fact, and third is non-additive fact. Okay, so based on these facts, remember these are the facts, not fact tables. Okay, these are the facts only, not fact table. So the based on these facts, there are two types of fact table. Okay, one is cumulative fact table. Okay, cumulative fact table, and the second one is snapshot fact table. Okay, based on the above facts, this is a cumulative fact. There are it is the fact tables are different two types. One is cumulative fact table, and other is snapshot fact table. So we'll see like what is. We know that fact will have a facts and measures, but what is additive fact? Okay, so additive fact is nothing but I will take an example. Okay, I will take an example so that we'll get to know what the clear picture on the additive fact. Imagine this is a table. It has like store key is the column. Okay, and it has product key is one more column, and also it has a transaction date key. Okay, and also the column is revenue. Okay, so this table has a one fact table. This is like something like store table or branch table. Okay, you can call it as a branch table. Okay, so store key can be like I can go with the S1. Okay, and the product key can be P1, and the transaction date. Suppose I will take what is that 11th. Okay, 11th September. 11th September 2023. Okay, and revenue will be like I will take 100, and same thing S2, and the product is P2, and this 11th September only I'm taking it. I'm taking some data to understand the clear picture of this fact table. Okay, this 200, and we have a S3 store. Store is nothing but branch, right? So it is a P3 and is the product, and also the same date and covering as a 300. Okay, so again the S1 store the product P2 will have some data, right? P2 will P2 is sale on the 20 September 2023. Generally, the data will be entered like this in the fact table. See, you are seeing the fact table like what I said, there will be some keys or IDs will be available in the fact table. And also, if you see, there is a revenue. Okay, this is the measure, and these are the facts. You can't change these facts, right? The store key cannot be changed, and product key cannot be changed, and transaction date will you change? No, right? So these things are available in the fact table. One more value I will take so that we will proceed with the explanation like how the fact will be behaved. Okay, product 3 can be sold on the 23rd September 2023 and the data is like 500. Fine. So from this table, so what is additive fact is nothing but it is where whatever the keys, right? Whatever the key is available, whatever you want to derive something, if you want to derive something, if you are summing up with the all the dimension keys in a fact table is known as a additive fact. What is dimension keys? These are generally available in the dimension tables. When I explain about the dimension tables, right, you will get a clear picture. These are the dimension keys which are available in the fact table. Okay, and these measures will be generated directly from the source tables. Okay, so these are the dimension keys. So when you want to derive from this fact table, something you want to derive, right? So you want to analyze, right? So to analyze that thing, if you are using all the dimension keys from the fact table, that is known as a what? Additive fact. So what we can you derive from here? So you can say like this, right? Store wise sales, right? Store wise sales you can do, right? Simply you can copy, you can do like this. You can do the analysis. So this is like a store key and can do the revenue, right? Okay. This is the revenue. And suppose that what are the store keys are available? S1, S2, S3. Overall, if you see, this is S1, S2 is the duplicated, right? So stores are like S1, S2, and again we will see one more column. Okay, one more column I'm adding S3. Okay, what is the revenue for this? So S1 will have revenue is 100 and for here 400. So total is 500. Like this, you will get the complete picture of the store and it is revenue for S2. S2, there is any other column, right? S2, 500 is there, right? 500 plus 600, 700, right? So 700 is the revenue for the store key. So like this, for each store, you can analyze the revenue of a particular store, right? And also in the case of the product, you can analyze the complete sales, right? What is the complete sales of the product? So like this over here, if you, I'm not going to do the table, so you could say P1 is the product. What is the P1 is that P1 will have, this is 100 and revenue and do we have any P1 here? No. So the revenue will be 100 only. The complete sales of the P1 is product 1 is 100 and the next P2 is, what is the P2? And 200 and 400 something like that. It's a 600. Okay. So and coming to the P3. What is P3? So how much is 300 plus 500 is 8. So like this, you can do the complete analysis on the table by using the all the dimension keys, all the summing up the all the dimension keys of a particular table that is known as a fact. Okay, additive fact that is known as additive fact. So here you can see like a daily revenue also, daily sales also you can get it by the transaction date, right? Per particular September, so what is the revenue at particular 12 September? What is the revenue? You can sum up with the data and you can say, and also you can say, on a particular store, on a particular product, on a particular date, so what is the revenue generated? That is also you can derive by using this table. That is why this is known as a additive fact. Okay. If you go with the example, right? So in additive, whatever you are explaining additive or semi-additive and non-additive, you have to go with the example. So everyone will have a clear picture on this additive or semi-additive or non-additive facts. Okay. So let's see about the semi-additive. You got it right? Any doubts in the additive fact? Any doubts?
No.
No, right? Okay, thanks. Okay, and semi-additive. Semi-additive is nothing but, so we are summing up. We are summing up if we want to derive something, from a table. If we are summing up some of the columns, not all the columns, some of the columns of it. Okay, to use based on that some of the columns, if you are deriving something, and that is known as a semi-additive fact. Okay, example, I will take it. Okay, I will take one example and let you know. Suppose there is a table like account table. Okay, account is the table, and if you have like account ID and also, so account ID and also like date ID. So the date is a fact, right? It is also fact, and also balance amount. In fact table, we have these things only, okay? And also profit, profit margin, okay? So these are the columns available in the account, okay? And this account is like something like that 101, and the date is something like we take it as September 2023. The balance amount is something like that, okay? Something like this, okay? Profit margin, it is something like 3.2 or some 3.4, something like that. Okay, the percentage, it is in the percentage. Okay, I will take it as a percent. Okay, so if you want to know a particular account on a particular day, what is the balance of this account, so you have to use only these three columns from this table. This profit margin is to separate for the bank, right? So we can't analyze on the profit margin on a particular account. Okay, so that is how, like, if you want to derive something like what is the account balance and what is the current balance, what is the previous balance, and you want to generate a report to the particular account, and for the balances and what, suppose if you want a minimum mini statement, right? Somewhere like in an ATM, you will get a mini statement. So there you will get only account information, not the bank information. So in this table, we have a four columns, but we are using only three columns. That is known as a semi-additive. Okay, this is a semi-additive. In semi-additive, we are not using the profit margin. So this is summing up with the only few dimension columns, and we are deriving something that is known as a semi-additive. Example is this, okay, for the semi-additive. So you can use this example in anywhere, okay, when you are going to explain about the semi-additive. Non-additive. Non-additive fact. So what is non-additive? So I will take the same example, okay, I will take the same example, but to derive something, right, to analyze something, you have to go with the what is what? So you have to use only one column of the table. Only one column of the table. What you are analyzing from this table? If you want to analyze the bank profit margin, okay. If you want to do the do the bank profit margin. What is the bank profit margin? So you don't require all these columns from the table, right? So only we require the profit margin column, and you can say, okay, so maybe here like we will have some year column, and what is the this year profit margin and what is the that year profit margin. You can simply write a query, and you can get the profit margin of the this account, right? Sorry, this bank. Okay, so that is called to analyze something. To analyze something, we need one of the column in fact table. We are using the one of the column, or you are summing up only with the one column that is known as a non-additive fact. Got this right? Additive, semi-additive, and non-additive. Additive is nothing but we are summing up with all the columns of the all the columns of the fact table, all the dimension keys of the fact table to derive something that is known as additive fact. Okay. And if you are summing up with the only sum of the columns to derive something, to analyze something that is known as a semi-additive. And if you are using only one column of the table to derive something, that is known as a non-additive fact. So these are the facts. An example is the one is like a store branch table and where it has a store key and product key and transaction date key and revenue. Three, these columns are available. So if you want to derive something like on a particular store and a particular product key and a particular day, what is the revenues generated? That is known as a, so we are going to derive this particular revenue to generate the particular revenue on these days. So we are summing up with the all the columns of the table that is known as a additive fact. And this is like these are the examples. Okay, if you want to say like this dimension also you have used like by using the store key, you can get the descriptive data. So when we are going to say about the dimension tables, right? So you will get what is using the dimension keys in a fact table. Okay, what can we how can what is the use of this dimension keys in a fact table and how that is going to be connected with the dimension table, that we will let you. Okay, I will let you know those things. But as of now, this is just remember this is the dimension key which is available in the fact table. Okay, for store wise information, we will get this, and also sales, that is product wise information also will get, and date wise information also will get. Like only if you take these two columns, you can get the date wise sales also will get. And coming to the cumulative fact table, what is snapshot fact table? Okay, cumulative fact table, cumulative fact table and snapshot fact table. What is cumulative fact table is nothing but if we are saying something about this one product, right? If we are saying this product, we are saying a particular period of time, like in a suppose in this month, right? In this month, what is the revenue of a particular product? Okay, what is the revenue of a particular product? You're saying something on a period of time. You are deriving something for a particular product in a period of time. That is known as a cumulative fact table. Okay, if you are deriving if deriving something in a period of time is known as a cumulative fact table. Okay, so example is that it is a additive fact. Example is additive fact, right? Additive fact. Okay, so cumulative fact table is nothing but to derive something over a period of time. Suppose like in a year 2023, what is the sale of the our business? Okay, and what are how many employees are joined in our business? So this is like a something like we are talking about the year, right? So that is known as a particular period of time. So that is called as a cumulative factor. And what is snapshot is, so if you are telling something in a state of a thing in an instance of time, that means, so if you go with the semi-additive, so on particular day, for a particular account, what is the balance? That means this day, okay, this day you are saying an instance of time. Suppose today only I want to know the balance, and this time, okay, for now, what is if I did some credit, right? If I did some purchase and I want to see the balance, so then is instance of time in a particular instance of time. So what is the balance of this account? It is known as what is the state of thing, whether this account has like a minus balance or a plus balance, or do want to see that, right? That is known as a snapshot fact tables. Okay, so it tells the state of thing in a instance of time is known as a snapshot fact table. Example is semi-additive and also non-additive. Non-additive will also come, right? So whether bank is in profit or more, profit or loss, you can say in a, by using the profit margin. Okay, non-additive. Okay, these are about the fact tables, different type of facts and different type of fact tables. And what is fact table? Fact table is nothing but it's the combination of facts and measures, and facts will be like a dimension keys from the dimension tables, and that we will know in the future class. Okay, and measures are something like that, measures and moral balance. Okay, do you have any questions here? Okay, I will take it as no.
Please
So
explain again the snapshot. Mm,
okay,
where
snapshot.
you said the snapshot is a instance of time where
Yes,
the semi-additive and the non-additive is the examples for a snapshot.
yes.
But to find the status of a bank or a account, we
Okay.
can derive the details from non-additive fact because we can come to know the profit margin of the account and all.
Yes.
And how it is useful by taking semi-additive fact table.
So don't take about the time of the like only for bank. Okay, if you are going for the insurance, okay, insurance company, if they want to also take in a profit margin like of the insurance company, or if you go with any grocery shop, they want to take a profit margin on a particular day or a particular hour. Like so, in that case also we go with the this snapshot fact. It was a non-additive. Okay, that is snapshot. Okay, sometimes the people wants to know current situation, what is the current situation of our organization or something like that, right? So in that case we go with the non-audit. So don't take in terms of the only bank is there. So we have multiple business. So in some multiple business we will have a multiple things to be known in an instance of time. Okay, so that is known as a non-audit, that is known as a snapshot fact table.
Okay.
Got it?
Yeah.
Okay. So here I give an example of profit margin. So no, this is not the thing like they want to know the instance of time. So there will be multiple things. Okay. So that is about the fact tables. Now we are moving into dimension tables. As I said, like yesterday, I have conveyed that. So what is dimension tables? It has a descriptive data. Okay. So descriptive data, what it means? What is descriptive data? Suppose if we take in, yeah, tell me. Suppose it's a accountable, okay, accountable. And also I said like fact table or account dim table, like it will come with a prefix like dim, right? Dim account like this, okay. So in a or in a project also generally if you see with the dim table, right, with the prefix with the dim, right? So that is a dimensional table, okay. And suppose an example of account ID. So first it will have an account key and account ID or account number and account name, okay, and also phone number and also address or location Like this, we will know like whatever the while you might have filled the bank account form sometimes, right? So you will give us some multiple data of yours like Gmail, phone number, address, location, and father's name, mother's name, like that, right? So whatever the account holder, right, who has the account in the bank is complete descriptive data. Like is whatever you fill in account, that complete data will be available in the dim dimension tables. Okay, so these dimension table will contain the complete descriptive data. Based on that, if you want to derive something like by using the fact table and dimension tables, so based so that we will have a relation between the fact and a dimension is nothing but account key, right? Here, this is the account ID, right? Here we will have one more key. I will write here account key. So this account key will be available in the only data warehouse, okay, not in database. Now database will have a data where using that account ID, but account key is nothing but a surrogate key that we will get to know in a future class. But this is known as a surrogate key, okay? This is available in the data warehouse. So based on this account key, we will have a relation between the fact and dimensions, so that you will get to know what is the balance of an account and his name and his phone number and his address, something like that. If you client want to send a message that, Sir, you have a limited, like you have a minus balance in your account, so that we will reduce some amount, we will do some fines on your account, so that like that message, if they want to send, they will have to know balance of the account and also the data, like also the details of the account name, accountant name, and the phone number, like that, right? So with this, if you are considering these two tables in a relation, and if you join with these two tables, you will get the information of the account name, and phone number, and so that you will send some message to them. So this is how the dimension and fact table have a relation, and dimension tables will have a multiple columns with the descriptive data. Okay, so these dimension tables, we will have a different type of dimension tables. One is confirmed dimension. Okay, confirmed dimension, and second one is degenerated dimension. Okay, and the third one is junk dimension. Okay, and fourth one is uh, confirmed dimension, junk dimension, role playing dimension. Role playing dimension, and slowly changing dimension. This is very important. Like wherever you are working with the ETL process, right? Slowly changing dimensions is the thing you are going to validate. Okay. So this is very important. In slowly changing dimension, we have a different types. Again, like is a type 1, type 2, type 3, type 4, and type 6. Those things we will see. And one more thing is a fastly changing dimension. Okay. Firstly, China. These are the main dimensions like which we work on our daily process in it as a ETL process. Okay, so what is compound dimension? What is degenerated dimension and Jing dimension? So we will see it tomorrow. But thing is that I will just give you some picture on this. Compound dimension is like I just now I said, like, right. So we have a fact and a dimension tables where we have a relation between the fact and dimensions, right? So if the dimensions are having a relationship with the fact table, only one fact table, and that is known as a and confirmed dimension, and this fact table will have a relation with the multiple dimension tables. So those is not as a that is known as a confirmed dimension. Okay, and degenerated dimension is nothing but this degenerated dimension will generate itself in a fact table. Tomorrow we will see with the examples so that you will have a clear picture. But degenerated dimension is nothing but what? So it is generated itself in a fact table. the key will be available in the fact table, but we can consider it as a dimension table or dimension key. Okay, sorry, dimension table. Okay, and junk dimension is nothing but where we have a multiple dimensions. If you see like in a these two tables, we are having a dimension keys here, right? If there is a two-dimension case, we should have a two case here for in a fact table, right? So in this case, so if there is a chance to combine these two dimension tables in a single dimension table, and in that case, you can maintain only one key in a fact table. See, like reducing the keys in a fact table will improve the performance of our ETL process. Okay, if you are having a multiple keys in the fact table, so you will have to join more. So if you are joining more, so the process will be improve more so that the performance will be low, right? So that is why reducing the key is also a key thing. That is why the junk dimension will be coming to the picture where if you want to reduce the keys in a fact table. Okay, that we can combine, we can go with we can see with the examples. Role playing dimension, like we will have a one key, that key will be available in the fact table, that is that key available in the dimension table, and it is having a relation between the multiple keys in a fact table. Okay, so one key available in the dimension table, that is having a relation between the multiple keys in a fact table. That is also role playing. It is playing a multiple roles. That is nothing but okay. So that is role playing dimension. Okay, and coming to the slowly changing dimension. So that is the part of like so where if we have a data, right? So where we have a dimension tables, we should maintain the like update data, like regular data, current data, and the previous data, whether we have to maintain the previous data or not, whether we will maintain only partial history data, something like that we can define in our dimension tables. That is called as type 1, type 2, type 3. So that is known as a slowly changing dimension. Okay. Fastly changing dimension, in some cases, in a dimension tables, there is a in an instance of time, there is a data will be changed. Okay, that is called as a fastly changing dimensions. In that some particular columns only there that will be changed in a 1 hour gap and a 2 hours gap, something like that. Okay, that data also we are going to capture in a dimension tables. That is known as a fastly changing dimension. Okay, so these are the dimension types. So tomorrow we will know like what are the dimension tables, what are the different type of dimensions, and with examples, and you will get a clear picture on these things. Okay, any doubts till now? If you have any doubts, let me know on these topics. Okay, otherwise we can move for the next class. Okay. And one more thing, I just want to remind you, like this is a day 3 class, right? So we are already done with the day 3 days. So if you want to continue in these classes and just touch base with the management, so for the further process, okay, I just want to inform you that thing, okay, so that we can continue all these things and we will go further. Okay, fine. Any doubts? Okay, we'll take it as a no. So that's it for today. So I'm going very slowly. Okay. Meanwhile, the starting will be very slow, and we will keep up it fast and in the next classes. Okay. So initially, I will start with this very slow. Okay. No problem, but you have to get the concept thing. Okay, and that's what my thing is to. My aim is to. Okay. Fine, right? Okay then. That's it for today. Have a nice day, guys.